Okay, picture this. You walk into a room and there's just um, this massive spool of black cable sitting
Yeah,
there.
it's like 1,000 feet, right?
Exactly, 1,000 feet, or 305 meters to be exact. To the untrained eye, it just looks like
Just boring wire.
yeah.
But if we connect this to the bigger picture, you're really looking at the invisible backbone of professional broadcasting.
Right, and that's exactly why we're doing this deep dive today. We're looking at this specific spool, the Kramer BC-RG63G-305M.
Rolls right off the tongue.
Yeah, it does. We're using data from HD-TV supply, and our mission is to basically figure out what separates this broadcast quality stuff from, what you'd buy at a hardware store.
Because when you're dealing with high-definition video, the physics gets really complicated really fast.
And the first clue is right in the specs. It says optimized for 3G HD-SDI.
Right.
So let's unpack that, because SDI is serial digital interface, but the 3G part, I think most people hear that and immediately think of old cellular networks.
Oh, absolutely. But we are definitely not talking about cell phones here. In this context, the 3G refers to bandwidth,
Got it.
specifically 3 gigabits per second, which is just a massive amount of uncompressed data to push down a single copper wire.
So it's kind of like trying to push a fire hose amount of water through a tiny garden hose.
Precisely. And the challenge is that high-definition signals are incredibly fragile.
They degrade over distance.
They do. They suffer from attenuation. The signal basically just runs out of energy and falls apart.
Yeah.
If you use standard consumer cable, you're going to get dropouts or artifacts or just a dead black screen.
And the source actually notes this Kramer cable is optimized for Sear Aspen routers, right?
Yes, those are very high-end routing systems.
Yeah.
This cable allows them to reach a system range of up to 500 feet without dropping the signal.
Which is wild. So how do they actually do it? Let's do a mental autopsy on this cable. If I take a knife and slice open that black PVC jacket, what am I looking at?
At the very center, you have the conductor. This one uses an 18 AWG solid bare copper core.
Wait, why specify solid? Because don't a lot of cables use stranded wire so they can bend easier?
Stranded is fine for short little patch cables, but for long runs, you really need solid copper. It has lower resistance and better conductivity.
So it maintains the fidelity over that full 300 meters.
Exactly. But the copper is only half the battle. The real magic where cheap cables fail is the shielding.
Because you have to protect the signal from outside interference?
Yeah, think about a TV studio. It is incredibly noisy, electronically speaking. You've got lights and power cables and wireless mics everywhere.
So this cable uses a dual shield design to block all that.
Right. First, you have a dual aluminum mylar foil, and the specs list its coverage at greater than or equal to 125%.
Okay, that part always gets me. How can coverage be over 100%? That just sounds like bad math.
It sounds like it, but it's actually brilliant engineering. It means the foil doesn't just meet at the edges, it overlaps itself significantly.
Like wrapping a burrito really tightly.
That is the perfect analogy. That overlap ensures that even when the cable is bent around corners, no gaps open up for interference to sneak in.
And then there's an aluminum braid on top of the foil.
Right. A braid with 95% coverage. It basically creates a continuous Faraday cage running the entire length of the studio.
That brings us to another really critical number in the specs, 75 ohms. The source is super specific about that specific impedance.
Oh yes, impedance is everything here.
Why does that exact number matter so much?
Well, think back to your water pipe analogy. The pipe has to be sized perfectly for the pressure of the signal. In video systems, literally everything from the camera to the connector to the router is designed for 75 ohms.
So what happens if the cable is off? Like, say it's 50 ohms instead.
The signal hits that mismatch and literally reflects back.
Reflects back like a wave hitting a wall?
Exactly like that. And that reflection creates what we call jitter in the data stream. It muddies the incoming signal and ruins the picture. Precision is completely non-negotiable.
But with all that precision, is it fragile? Because installers are usually yanking these things through walls and ceilings all day.
That is the tricky balance. But the source emphasizes a rugged and flexible design with that PVC jacket. It's built to be pulled through conduit without kinking.
Because kinking would ruin that internal geometry and mess up the 75 ohms.
You got it. And despite all these high specs, it's still compatible with standard Kramer compression connectors and typical crimp systems.
Which is great for the technicians actually doing the work. HD-TV Supply actually mentions this. They call themselves a 25-year global home for AV products.
Right. They understand the professional ecosystem. You need a cable that any technician can reliably terminate in the field.
It really does change how you look at a simple reel of wire. We always tend to think the technology is all about the fancy cameras and the bright screens.
But the physical copper is the highway. And if the highway is full of potholes, it doesn't matter if you're driving a Ferrari.
That is a great way to put it. So here is a final thought for you to take away from this deep dive.
Go for it.
We obsess over things like resolution and HDR and camera sensors, but we rarely think about the physical connection making all of that possible. If the cable is the absolute weakest link in your chain, does the quality of your expensive camera even matter?
A question every single system integrator needs to ask themselves.
Definitely. Thanks for joining us on this deep dive.